Okay, part 2 is where things get a little more complicated. And here's why. So if I compare my 2 distributions that we've been working with, this is my Z, purple's my Z, pink is my T. These values on the inside of your purple table are your p-value. So inside the table is your p-value, and on the edge of your table is your Z value. So we calculate a Z critical, and then we go inside the table to get our p-value. Well, T distribution is the exact opposite. So what you see inside the table is your critical value. And not only that, but your critical value is based off a specific degrees of freedom. So that's one thing that's different. But then the other thing that's different is that your p-values are this top line where it says tail probability. We only have, 10, 12 possible p-values that we can get from this table. So if we use the table, these are literally the only p-values that we have to consider. It starts really small at 0.05% and goes up to a p-value of 25%. Because it's backward of the Z table, so because our T critical is inside and our p-value has to be one of these 12 numbers, the process is a little bit more confusing, honestly, I think is the best word. So we'll look at a few examples to hopefully get you comfortable with this idea. The formula for our test statistic, which is T, is the same as for the formula for Z. You take your sample value, subtract your null value, and then divide by your standard error. So the specific elements are right here. So we're going to calculate the T for our battery data. So our sample value from the battery data was 33.9. So sample value, those batteries lasted 33.9 hours. Subtract the value from our hypotheses, so 30. Divided by your standard error of your sample, which given on the previous page was 9.8, divided by the root of your sample size, which is 15. Is that true? Yes. So if we plug this big fraction into our calculator, we're going to get a T critical of 1.54. 1.54-ish. Okay, so I'm going to look for this number inside of my pink table. But remember, where I look depends on my degrees of freedom. So above this table, I'm going to calculate my degrees of freedom. 15 minus 1 equals 14. So I would go to the 14 line on my table, and I would scooch to the right until I found 1.54. I'm double checking. So it's between these two numbers, 1345 and 1761. I have that same part of our T table right here. So this is a snip of your T table. Our value of T, 1.54, it turns out that it's almost exactly in the middle of this interval. So typically, what we would say when using the table is that our p-value is, and then we come to the top of this table and give the percents that our t-critical is between. We always give a range of values. So in this case, our p-value is somewhere between 5% and 10%. So unfortunately, if we use our t-table, the best that we can get is a range of values. This problem is a little bit special in that this number is truly almost exactly between these two percents. So what's exactly between 5% and 10%? 7.5%. So if we found the true p-value, so the actual closest number to our true p-value, it's going to be about 7.5%. It rarely happens that it's like this, though. It's mostly that we have to give a range. We can still make a conclusion, though. So as you can see, using a t-table gives an interval of p-values. So in this case, our interval is that our p-value is 5 to 10%. We can still draw a conclusion from the test in much the same way as if we actually had a specific value. In the case of these AAA batteries, for instance, we would fail to reject the null because our p-value exceeds our default significance level of alpha is 5%. So in the problem, they didn't tell us what alpha to test at, so we would use 5%. Well, we know that our p-value is in the middle of 5 to 10%. So that would be a fail to reject. Our p-value is not low. Based on this, we do not have convincing evidence that the company's new batteries last longer than 30 hours on average. So even though our sample gave us an average of 34 hours, that's not enough for us to conclude that they truly last longer. Now, I don't know about you guys, but I don't particularly enjoy giving the range of values. I know that I need to understand how to do it, but I personally like for things to be right or wrong. So because of that, we can actually use our calculator to find the specific p-value so that we can feel better about whether or not we're right or wrong. So I'm going to write down the buttons as we do this. So using our calculator, we would hit our stat button. And then we're going to arrow over to tests because that's the unit that we're in. So we're going to arrow over to tests. We today are doing a t-test. Last time was a z-test. Today is a t-test, so t-critical value. So we choose option 2, t-test. Then it's going to give us an option. If we have the data set, we can hit data. And if we just have the statistics, we hit stats. For this particular example, we have the statistics. So we have the x-bar and the mu and the standard deviation. So for this problem, we're going to use stats. So mu sub 0 is the value that we used for our null. So that would be 30 hours. The batteries last 30 hours. Our sample mean was 33.9 hours. Our standard deviation of our sample is 9.8 hours. And our sample size was 15. This is where they're asking us, is it a one-sided test or a two-sided? Ours is one-sided, and we're testing that the batteries last longer. So we have a greater than situation. So I know that from these hypotheses. I choose mu greater. Okay, if you hit or select calculate, it's going to give you the values. So the T critical value is 1.54, just like we got. The true p-value is 0.0728. So from our calculator, our p-value is 0.0728, which we knew it was going to be around there because we estimated that it would be about 7.5%. And it turns out that it's 7.3%. So we got pretty close just using our table. If you hit draw, and I think I like draw a little bit better, it's actually going to draw the normal curve, shade in the area that you found, and give you your T and your P. So T critical, probability that we would get the sample we got, what that looks like on a normal curve. I think that's pretty cool. So we have two options, and on our problems, we're going to practice both. We're going to use our calculator and give a range of values because this often comes up on our multiple choice. Okay, so let's try one. You have one very similar to this on your check for understanding. So each check for understanding that you have today is very similar to one of the problems we do in class. So this one is, the makers of Aspro brand aspirin want to be sure that their tablets contain the right amount of active ingredient, which is acetylsalicylic acid. I don't know if that's really how you say it. Acetylic sassafras acid. I don't know. How do you say this? Do you guys know? Aaliyah. You don't know? Oh, heavens. I wonder if you have to learn how to say all these in nursing school or like pharmacy school. I bet you that you do. Acetylsalicylic acid. That might be close. Do you know it? Oh, smart. You should be a pharmacist. Okay, Sophia knew how to say it. Okay, so they inspect a random sample of 36 tablets from a batch in production. When the production process is working properly, the Aspro tablets have an average of 320 milligrams of the active ingredient. The amount of active ingredient in the 36 selected tablets was 319. Our standard deviation is 3. So they give us quite a bit of info here. We have our sample mean. We have our sample standard deviation. And we have our null value. So first question says, state the appropriate hypotheses for this test. So the null is that mu is equal to 320 milligrams, because it says when the production process is working properly, we should be at about 320. HA, the makers want to be sure that the right amount. Oh no. Our alternative is two-sided. We're checking to see if the process is working properly, which means that we're not specifically looking that it's less than, we're not looking that it's more than, we're looking to see if it is different. Does that make sense? So difference means two-sided. Okay, 2. Calculate the test statistic, show your work. So T is equal to sample mean 319 subtract null value 320 divided by standard deviation 3 over root of our sample size, which is 36. And now I'm going to cheat a little bit because I know that my calculator will do this for me using the t-test. And I would rather run the t-test than type this big fraction in. So that's what I'm going to do. I'm going to go to Stat, Test, choose option 2, and I'm going to change my stats to match this problem. So my null was 320. Sample was 319. Standard deviation 3. Sample size 36. And this time we have a not equals 2, a two-sided. I'm going to draw this one. So this gives me my normal curve with my two tails filled in and a t-value of -2. So if you would have plugged that thing into your calculator, it would have given you -2. Then I can see down here that it says use your calculator to get an accurate p-value. Well, my calculator gave me 0.0533. I skipped over, though, the harder question, which was use the table to give a range for my p-value. What makes this a little bit complicated is the fact that this has two tails filled in. So I'm going to sketch this for myself on my paper. Here's my t distribution. 0 is in the middle. And we go 1, 2, 3, just like we do in our standard normal. And we got a t critical of -2. And I remember from last time, well, maybe it wasn't last time, but when we talked about one and two-sided tests, that if it's a two-sided test, I have to take this area and reflect it now to the other tail. So I do a boundary at t is 2 and fill in the right-hand side. Okay, then I would go to my pink table. Oh, I gotta know my degrees of freedom. My degrees of freedom is 36 minus 1, which would be 35, but that's not on our table, so what do we use? Instead of 35, 30. Okay, so this table doesn't have any negative values, but that's okay. We can just use the positive 2 instead of the negative 2. So I'm going to go to the 30 row. It's at the bottom of a gray section, and I'm looking for 2. So I have that it would be in between 1697 and 2042. So if I follow that up to the top of my table, this gives me the p-value that matches that. So this T critical is in between 2.5% and 5%. Two and a half percent and 5%. Well, I already know what our p-value is, and it's 5%. It's 5.33%. So why does this say 2.5 to 5? Well, you got 2 tails. So you also have to do the area from this side. So now what this really means is that our p-value from the table is any value, well, I shouldn't say any value, is between 5% and 10%. Maybe I should say p-value is in. P-value is between. P-value is in the interval. I think that that's probably more specific. What do they say in our multiple choice? Because I want to make sure that I'm getting this correctly. P-value falls between. %5 and 10%. Which then matches what our calculator gave us. Our calculator gave us 5.33. That is between 5 and 10. So I had to add the lower percent, 2.5 plus 2.5, that's where I got 5. And the large percent, the larger one, 5 and 5, that's where we get 10. Is that making a little bit of sense? Smidgeroo? Smidgen? Okay, so you'll have an opportunity to practice this on the next 2 problems that we do, but I'll also give you 1 or 2 in Canvas. It gets easier the more you see. Okay, so that's part 2.